Okay, let's talk about simultaneous linear equations a little bit more. I'm going to talk about, in this instance, some of the issue with, let's talk about what this thing is first before I show the issue. I want you to remember the general form for a linear equation is y is equal to mx plus c. Okay, that's the general form. Because often, when you get a linear equation, for example, here's a couple, they're not in that general form. They're not written in terms of y being equal to something else. And normally, okay, that's not so bad. But there's an issue with this pair here. And I want to go through that real quick. But in order to see what the issue is, we need them to be in that form of y is equal to mx plus c. So let's work each of these equations until they are in that form. So here we have our 2x minus y equals 5. I'm going to take away 2x from both sides. And then I'll have negative y is equal to negative 2x plus 5. I'm going to multiply each term by negative 1 so that I can get rid of the negative y. I don't want that there. And I'm going to end up with y is equal to 2x minus 5. Now it's in the general form that we have up above. All right, let's have a look at the next one. Here we have the second equation. We had 4x minus 2y is equal to 6. I'm going to take away 4x from both sides. I'm then going to end up with negative 2y is equal to negative 4x plus 6. I'm going to divide each term by negative 2. And I'm going to end up with y is equal to 2x minus 3. Okay, so, and here's our general form so that you can remember. Now, the important thing to remember about the general form is, and by the way, this is a lowercase m. It just didn't work that way. M is equal to what? What is m? What does it represent? Well, it represents the gradient of my linear equation. Now, if you have a look at my gradient on my first equation and my gradient in my second equation, you'll see that the gradient happens to be the same. And that's a problem in terms of finding a solution for these two linear equations. Really quickly, let me show you what a graph of these two would look like. Now, this is a site called Desmos. I recommend it if you're doing any of these linear equations and graphing and that sort of stuff. It's excellent. Okay, so here I have my 2x minus y equals 5 and my 4x minus 2y equals 6. And you'll see that even on this zoomed in version, these two lines are parallel. And I could zoom out and zoom out and zoom out and show more and more of these two lines. And even as they recede into the background, they are still separated and they will never cross. And if the two lines don't ever actually cross over, there's no solution for the two of those linear equations. Okay. Now, there can also be an instance where, well, what would happen if these two lines with the same gradient, what if they were on exactly the same point? What if they had the same y-intercept? Okay, now if that happens, if you've got two linear equations and they end up tracing along exactly the same line, well, that means they have every point in common. And there's no real solution then either, because every point is a solution. Okay, so they're the two things to watch out for when you're trying to find these simultaneous linear equation solutions. There's sometimes that you can have them where there is no solution, and sometimes you can have them as instances where they're all the solutions, every point. So just so long as you're aware of that, so if you ever come across a set of these linear equations and there's no solution, check the gradient, because that might be the reason why.